We've already discussed the answer to the first one in the last class, but I would just like to repeat that for those who still feel it's not a part of the syllabus. The angle might look like, or the angle is not a standard angle, 15 degrees. But to find the value of sine 15, you will be working with standard angles 45 and 30 degrees or 60 degrees and 45 degrees. To find the value of sine 15 degrees, you'll be working with standard angles and the values of the trigonometric ratios of the standard angles. So it is very much a part of your syllabus. Let's see how the answer goes. See, in the question, we are given a formula to evaluate or to find the value of sine of an angle. So here we have to find sine 15 degrees. To find the value of sine 15 degrees, we have a formula given to us in the question. And the formula goes like this: sine of A minus B is equal to sine A cos B minus cos A sine B. This formula is given to us and will be given. You don't have to memorize this. This will be given to you. With the help of this formula, you need to evaluate or find the value of sine 15 degrees. Now we have A minus B here, sine A minus B, sine of A minus B. And we know that the standard angles which we are dealing with are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And 60 degrees minus 45 degrees is 15 degrees. 60 minus 45 is 15. Also, 45 minus 30 is 15. So you can take A as 60 degrees and B as 45 degrees, or you can take A 45 degrees, B 30 degrees, because the difference is 15. The difference is 15. Why difference? Because the formula is sine of A minus B. So let A be 45 degrees, B 30 degrees. You can also take 60 and 45. You will get the same result. So let A be 45 degrees, B be 30 degrees. So now use the values in this formula. Sine of A minus B. So sine of 45 degrees minus 30 degrees is equal to sine A, sine 45, cos B, cos 30, minus cos A, cos 45, sine B, sine 30. Now 45 minus 30 is 15. 45 minus 30 is 15. So sine 15 degrees is equal to. So get all these values from the table. 1 into root 3 is root 3. 2 into root 2 is 2 root 2. 1 into 1, 1. 2 into root 2, 2 root 2. So common denominator 2 root 2. So you have root 3 minus 1 by 2 root 2. The denominator is irrational. You can see root 2 here in the denominator. Irrational. So rationalize the denominator. Multiply and divide by root 2. Multiply and divide by root 2. So that gives you this, and further on multiplying, opening the bracket, you get root 6 minus root 2 by 4. So this is the value of sine 15 degrees with the rational denominator. See, this is the value. This is the value of sine 15 degrees. The denominator is irrational. So we perform these steps to rationalize the denominator. And it is root 6 minus root 2 by 4. We also have to find the value of cos 15 degrees in the question. Find cos 15 degrees. And we have another formula given to us. Cos of A minus B is cos A cos B plus sin A sin B. Again, 15 degrees we need to find. So you can change. You can take 60 and 45 here. See, the result will not change. The final answer will be the same. So I have taken the same A 45, B 30. Repeat the procedure. Use this formula and repeat this procedure. Use this formula and work it in the same way. So you can see you get root 3 plus 1 by 2 root 2. Rationalize the denominator, and that gives you root 6 plus root 2 by 4. So in question number 1, we have to find the value of sine 15 degrees, cos 15 degrees. Given the formula, given this formula to find sine 15 degrees and given this formula to find cos 15 degrees. In question number 2, we have a trigonometric ratio given to us. Tan theta is equal to 2mn by m square minus n square. So a trigonometric ratio is given to you. We need to find the other t ratios. That is sine theta, cos theta, cosecant theta, secant theta, and cot theta. We need to find the other t ratios of theta. So use a right triangle. Use a right triangle. Call it ABC, PQR. Theta should be an acute angle. You cannot mark theta here. You cannot mark theta here. Theta is an acute angle. So you can mark theta here or you can mark it here. Any one of these two places. Because this is 90 degrees. Okay. So I have marked this angle to be theta. This one is theta. Now we are given tan theta is equal to 2mn by m square minus n square. We know that tan theta is opposite by adjacent. Opposite side by adjacent side. So this is theta. So opposite side 2mn by adjacent. You can see here m square minus n square. You can see here theta opposite side 2mn adjacent side m square minus n square. Now find BC using Pythagoras theorem. BC is equal to square root of m square minus n square the whole square plus 2mn the whole square. Pythagoras theorem, you know it well. All right. So this is nothing but don't expand. So I was telling you about the identities in the last class. Very useful, very important identities. A plus b the whole square minus a minus b the whole square is equal to 4ab. So from this we have other identities like this. On transposing we get a plus b the whole square is equal to a minus b the whole square plus 4ab. Also a minus b the whole square is equal to a plus b the whole square minus 4ab. Simply by transposing we get the other two. Just by transposing. Remember this one. A plus b the whole square minus a minus b the whole square is equal to 4ab. Now a plus b the whole square will be, take this to the other side. A minus b the whole square plus 4ab. To find a minus b the whole square, take this to the right hand side. And this one here. So we have a minus b the whole square is equal to a plus b the whole square minus 4ab. Okay. So now this is of the form a minus b the whole square plus 4ab. You can see a is m square, b is n square, a minus b the whole square plus 4ab, 4 into a m square b n square. A minus b whole square plus 4ab. A is m square, b is n square. A minus b whole square. So a minus b the whole square plus 4ab. See here, what is a minus b the whole square plus 4ab? It's a plus b the whole square, which means m square plus n square the whole square. Because a plus b the whole square, a is m square, b is n square, a plus b the whole square, all under the square root. Square root of, we have square root of a minus b the whole square plus 4ab. So it is square root of a plus b the whole square. You can see I've mentioned the identity here. So now the square and the square root, they get cancelled. So we have BC is equal to m square plus n square. BC, this one is m square plus n square. Now find the other ratios. Now you can find sine theta. Sine theta is opposite to mn by hypotenuse, m square plus n square. Cos theta, adjacent, m square minus n square by hypotenuse, m square plus n square. Once you find sine theta, you can find its reciprocal, cosecant theta. Once you find sine theta, its reciprocal is cosecant theta, right? So cosecant theta would be, take the reciprocal of this one, m square plus n square by 2mn. And once you find cos theta, its reciprocal secant theta. Take the reciprocal of this one. So find sine theta and cos theta, and using reciprocal ratios, the reciprocal of sine theta is cosecant theta. So simply take the reciprocal of this, and the reciprocal of cos theta is secant theta. So find cos theta, and the reciprocal of cos theta is secant theta. And tan theta is already given to you in the question, 2mn by m square minus n square. So cot theta is a reciprocal of tan theta, m square minus n square, this one. Reciprocal of tan is cot, so m square minus n square by 2mn. So this part here, I would say, is very important. This one, identifying that this is of the form. Don't see, whenever you have a minus b the whole square or a plus b the whole square, don't expand it. Don't expand. Like see here, you have something which looks like a minus b the whole square. Don't expand it. Simplify this one. This one is 4m square n square. 4m square n square. Don't expand this. When you have something like a plus b the whole square or a minus b the whole square, do not expand. Work on this one. So you get 4m square n square. Now this is a, this is b. You can see here a and b here. So how do you read this? A minus b whole square plus 4ab. A is this one. This is A, this is B. You can see the same thing here, A and B. So by the identity, it is A plus B the whole square. So that's about the second one. In question number 3. Angle B is 90 degrees. And this is the midpoint of BD. This is the midpoint of BD. C is the midpoint. BD is A. The whole thing is A. BD is A. This is the midpoint. So this will be A by 2. And the CD is A by 2. BC is A by 2 because C is the midpoint of BD. BAC is theta. BAC, this one is theta. BAC, see here, BAC is theta. AD is B, B units. Find sine theta and cos theta. See, theta is here in this triangle. This is A by 2. This is A by 2. And this is B. So since theta is an acute angle of the right triangle ABC, you need to know the sides of this triangle to find the ratios, sine theta and cos theta. Theta is an angle or an acute angle of this small triangle ABC. 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 Here we know that BC is A by 2. This is theta. Now sine theta is opposite by hypotenuse. You don't know the hypotenuse. Cos theta is adjacent by hypotenuse. Adjacent by hypotenuse. We don't know. So we need to find AB and AC in order to find the ratio sine theta and cos theta. So find AB using Pythagoras theorem in the whole triangle. You know that this is A and this is B. The whole thing is a right triangle. This is A, and this one, the hypotenuse here is B. So using Pythagoras theorem, you can find AB. You can find AB. This full thing is A. This full thing is B. A, B. So use Pythagoras theorem, the whole triangle, and find AB. So once you find AB, using this and this one, you can find the hypotenuse here. Pythagoras theorem. Once you find AB and BC, you can find the hypotenuse AC. So you need to first find AB and AC, and only then you can find sine theta and cos theta. Because theta is an angle of this little triangle, ABC. So you need to know the sides of this triangle to find sine theta and cos theta. See, your angle BAC is theta. BAC is this angle. Yeah, I'll just give me a minute, children. I'll show you the answer slide. Please help yourself. I'll just come back. Yes, so you can see the answer here. Find AB, find AC, and then find sine theta and cos theta.
Ma'am, could you please show the previous slide for a second?
Oh, yeah, sure.
Thank you, ma'am.
Yeah. So in the whole triangle, we have BD square plus AB square is equal to AD square. The whole triangle. BD square plus AB square is equal to AD square. So what is BD? A square plus AB square. This is what we have to find is equal to AD square, B square. So AB square is equal to B square minus A square. So AB is equal to square root of B square minus A square, which is not B minus A, which is not B minus A. Square root of B square into A square is B into A. So when it is square root of B square minus A square, you'll have to find this difference and then take the square root of the difference. You cannot find the individual square roots. You need to subtract and then take the square root. So remember, it is not equal to B minus A. So like this, we find AB. After finding AB, now we need to find in that little triangle ABC, we need to find AC. So AC square is equal to AB square plus BC square. AB square, children. See, you can take this straight away, children. See, AB square you have here. No, you can take this straight away. You have AB square here. You can take that straight away. So B square minus A square plus BC square. BC is A by 2. So A by 2 the whole square. A square by 4. Then upon taking the LCM and all that, you get AC square is equal to 4B square minus 3A square by 4 on taking the LCM. So AC is equal to square root of AC will be the square root of this one. And since the denominator is 4, which is the perfect square, AC will be equal to, take the square root only for the numerator, square root of 4B square minus 3A square divided by 2. Don't extend the square root symbol to the denominator because earlier it was like that, but then square root of 4 is 2. So like this, we find AC. Now find sine theta and cos theta. Opposite by hypotenuse. And adjacent by hypotenuse for cos theta. Yeah. Any further questions regarding simplification, please ask me. You don't have to directly write this, children. See, you don't have to write it directly like this. You can start off like the way I explained now also. Like this. You don't have to write straight away that AB is square root of whatever you see here. You can start off like this. Okay. Next one. So if you have sine of A plus B is equal to root 3 by 2. Okay. So sine of A plus B is equal to, we know that sine 60 degrees is root 3 by 2. Sine 60 degrees is root 3 by 2. So replace root 3 by 2 with sine 60 degrees. If this is given, you're given that sine of A plus B is root 3 by 2. So sine of A plus B is equal to, write root 3 by 2 as sine 60 degrees. Now comparing both the sides, you cannot cancel sine and sine, children. You cannot cancel, but just if you can cancel sine and sine, what is that you're left with? A plus B is equal to 60 degrees. So on comparing both the sides, you cannot cancel like this. On comparing both the sides, we have A plus B is equal to 60 degrees. So A plus B is equal to 60 is an equation. In the same way here, in the same way, in question number 5, we have sine of A plus B plus C is equal to 1. Sine of A plus B plus C is 1. So sine of what angle is 1?
90 degrees, ma'am.
Sine 90 is 1. So that means A plus B plus C is equal to 90. And then in the tan table, tan of what angle is 1 by 3? 1 by root 3?
30 degrees, ma'am.
30. And 2 in secant table? 60. 60. Very good. Has anyone completed this and got the values for A, B, and C?
Ma'am, value of A is 60, B is 30, and C is 0.
60, 30, 0. Oh, I missed the fourth one, huh? Emily? Oh, I missed the fourth one. I'm sorry. Okay. Okay, 4 is quite similar to the third one. So given tan A, children, given tan A, you need to find the value of this expression. So again, use a right triangle. Tan A is 2, meaning 2 by 1. Tan A is 2, meaning 2 by 1. So 2 is the opposite side. Adjacent side is 1. See this triangle, I've named it ABC. Tan A meaning tan of angle A, this one. ABC is the right triangle. You have given, you have tan A. So you cannot mark A here, children. You cannot mark A here. The angle here A is an acute angle. So you cannot mark A here. A has to be here or here, one of the two acute angles. So I've marked it here. Tan A, meaning tan of this angle. Opposite by adjacent. Opposite is 2, adjacent is 1. 2 means 2 by 1. This is the opposite, this is the adjacent. A, opposite by adjacent. So you have 2 and 1 here. You can find the hypotenuse using Pythagoras theorem. It's root 5. And then find all the ratios which are needed in the to be substituted in the expression sine A, secant A, tan A, and cosecant A. Find them using the definitions. Sine A is opposite by hypotenuse. Secant A is hypotenuse by adjacent. Tan A is opposite by adjacent. Cosecant is hypotenuse by opposite. Using the definitions, find and using the triangle, find all this, substitute and evaluate. And in 5, so like this, you get 3 equations. One is replaced with sine 90. And on comparing both the sides, A plus B plus C is 90. And then we had 1 by root 3 here, 1 by root 3. And that's nothing but tan 30. So A minus B is 30 on comparing both the sides. On comparing, like as if tan and tan gets cancelled. A minus B is equal to 30. Please do not cancel. Because when we say tan 30 degrees, tan and 30 degrees, they're not separable. Tan 30 is one thing. Like in A and B are separable. A into B. They have their own identities. A is A, B is B. And together they are AB. But here in tan 30 degrees, it is meaningful only as a whole. Tan 30 degrees is one whole thing. You cannot look at it as tan into 30 degrees. It's not tan into 30 degrees. Tan 30 degrees is one whole. So you cannot, in that sense, you cannot cancel. See, if you had xy is equal to xz, you can cancel x on both sides because they have independent identities. But here, tan of A minus B is one thing. Tan 30 is one thing. So from that, you cannot cancel tan and tan because they don't exist separately like that in these expressions. So on comparing both the sides, A minus B is 30 and A plus C is 60. Solve the equations and find the values of A, B, and C. So the working here is A plus B plus C is 90 we have. So you can see that in this one and this one, in these two, we have A common. A is common. Okay, so I have written I've written B as A minus 30. So I've written B and C in terms of A. I've written B and C in terms of A. B is A minus 30 and C is 60 minus A. Now substitute this in A plus B plus C is 90. A plus B plus C is 90. But what is, you write A as A. What is B? B is A minus 30. And what is C? 60 minus A. So now this equation has only A in it. Now you work this and find the value of A. A plus B plus C is equal to 90. Now these two equations have A in them, common. So write B in terms of A and C also in terms of A. So now use these two in this equation. A plus B plus C is 90. So B is what? A minus 30. B is A minus 30. And C is 60 minus A. And this is A. So now there's only one unknown A. The equation has only one unknown A. So work that and find the value of A. Just a minute, children. Yeah, thank you, children. Yeah, please ask me anything not clear from my side.
No doubts, ma'am.
All right. So this is a very common question, children. This one is very common. So take care. Then this one also is very important. I think after the fifth one, 6 and 7, yeah, not for you. This is the 8th one, correct? 6, 7, right? Yeah, 6 and 7 deleted. 8. Yeah. So this again is important. See, in a triangle ABC, right angle at B, AB is given and BC plus AC is equal to 49. Find sin A and secant C. Right angle at B. AB is 21 and BC plus AC, that is the sum of the remaining two sides, is 49. The sum of the remaining two sides, BC plus AC, is 49. See here, BC plus AC is 49. So you can either write BC is equal to 49 minus AC, or you can write AC is equal to 49 minus BC, any one of the two. Take BC as 49 minus AC, or you take AC as 49 minus BC. Now, supposing you write AC as 49 minus BC, AC is 49 minus BC. BC is BC only. BC is BC. This is 21. This is 49 minus BC. So when you apply Pythagoras theorem in this triangle, you will be able to find the length of BC. And once you find BC, you can substitute here 49 minus BC, you will get AC. And then you can find the values of sin A and secant C. We will see it again. Triangle. Triangle, right angle at B. AB is 21. BC plus AC is equal to 49. You can either write BC is equal to 49 minus AC, or you can write AC is equal to 49 minus BC. Any one of the two. BC plus AC is 49, so BC is 49 minus AC, or AC is 49 minus BC. Now, supposing you take this one, BC is 49 minus AC. What is BC? BC is 49 minus AC. Then let AC be AC only. Now, how do you apply Pythagoras theorem? The square on this side, AB square, so 21 the whole square, plus BC square, 49 minus AC the whole square, is equal to AC square. Pythagoras theorem. AB square, 21 square, plus BC square, 49 minus AC the whole square, is equal to the hypotenuse square, AC square. Now you can see that this equation has only one unknown, AC. So you can work this and find the value of AC. Once you find AC, you will get this one, right? Then 49 minus AC will give you the length of BC. And then once you have all the three sides of the triangle, you can find the values of sin A and secant C. So I've taken BC as 49 minus AC. So BC, this one is 49 minus AC. AC is AC. AC is AC. So Pythagoras theorem, AC square is equal to AB square plus BC square. While expanding this, you'll have to be careful. This is A minus B the whole square, which is A square minus 2AB plus B square. Don't forget to write this middle term, minus 2AB. A minus B, BC square. A minus B the whole square. A square minus 2AB plus B square. So AC square on either side gets cancelled. So on solving, you find AC is 29. So if AC is 29, then BC is 49 minus 29. It is 20. So you got this is 29. This is 20. Now find sin A and secant C. So sin A. So be careful, children. Sin A. Sine of angle A. So sin A is equal to, see here, sin A is equal to, which is the side opposite to angle A? BC by hypotenuse. Sin A is equal to the side opposite to angle A by the hypotenuse. So BC by AC. Secant C, secant of this angle. So secant is a reciprocal of cos. Cos is what? Adjacent by hypotenuse. So secant is hypotenuse by adjacent. Secant is hypotenuse by adjacent. Secant of angle C, secant of angle C, hypotenuse by adjacent. For angle, this is the hypotenuse. Now for angle C, this is the adjacent side. For angle A, this is the adjacent side. For angle A, this is the opposite side. So you'll have to find sin A and secant C. So secant C meaning secant of this angle, which is hypotenuse by adjacent, hypotenuse AC by adjacent BC, 29 by 20. Okay. I'll just share one, we'll just recall one particular concept from exponents so that with the help of that, you will be able to understand this. We'll discuss this in the class tomorrow. Just ignore this part, children. Ignore this, okay? I'll share all these images on WhatsApp. So it's okay if you were not able to capture a screenshot. Ignore this part. So you can see the answer here for the last one. You can see the answer here for the last one. I think in the question you have x cube and y cube, but here you can see it as a cubed and b cubed. In the question there, I think it is x cubed and y cubed, but here it's the same thing, but a cubed, a and b instead of x and y, it's a and b here. So children, we'll have to find a square, b square. See, the last question, this question, they're similar. It's ab here, it's xy there. So let me just explain this one. We need to show that a square, b square into a square plus b square is 1. So I'll just tell you how to find a and b. Once you find a and b, you can substitute this, work and find work, and eventually you will get the value of the expression as 1. So this part is what I wanted to tell you. If a cubed, see a cubed we have is cos square theta by sin theta. So a is equal to cube root of cos square theta by sin theta. So cube root means to the power 1 by 3. Cube root. This is the radical form. Cube root, when you write it like this is the radical form. If you want to write the same thing in the exponential form, then the cube root will look like to the power 1 by 3. If it is square root, it will be to the power 1 by 2. Fourth root to the power 1 by 4, and so on. So cube root, meaning to the power 1 by 3. And again, by the law of exponents, when the base is raised to many powers, like when you have a square, the whole power 1 by 3, a square, the whole power 1 by 3, you'll have to multiply the powers, 2 into 1 by 3. So a to the power 2 by 3. A to the power 2 by 3. So that's what we do here. Cos square theta to the power 1 by 3. So it will be cos theta, multiply the powers. 2 into 1 by 3 is 2 by 3. So it is cos theta to the power 2 by 3. Cos theta to the power 2 by 3. Multiply the powers. 2 into 1 by 3 is 2 by 3. And that's applicable to the numerator and the denominator. Now this is sin theta. Sin theta to the power 1 by 3 is sin theta. This is how you write it. Sin theta to the power 1 by 3. The power 1 by 3, the power 1 by 3 is to be applied to both the numerator and the denominator. So here the numerator will be 2 into 1 by 3, 2 by 3. Denominator sin theta. That means it's 1 here. So like 1 into 1 by 3 is 1 by 3. So sin theta to the power 1 by 3. Repeat the same thing for B. B. Now substitute. So again, multiply the power. See, 2 by 3 into 2 is 4 by 3. 1 by 3 into 2 is 2 by 3. Multiplying the powers by the law of exponents. The base is cos theta. The base is cos theta. It's raised to the power 2 by 3 and another power 2. The base cos theta is raised to the power 2 by 3 and another power 2. Multiply the powers. 2 by 3 into 2. 4 by 3. And this is where you write it. Cos theta to the power 4 by 3 like this. Not like this. Not like this. This is wrong. Write the power here. Similarly here, sine theta is the base. It's raised to the power 2 by 3. And again, raised to the power 2. So multiply the powers. 2 by 3 into 2. 2 by 3 into 2 is 4 by 3. So sine theta to the power 4 by 3. So that's one thing you'll have to remember about using or applying the laws of exponents. Multiplying the powers. When the base is raised to many powers, is raised to the power n, is raised to the power n. So it is a to the power m n p. Multiply the powers. A into m, a to the power m into n into p. And the other thing is, when bases are same and it's division, we subtract the powers. When bases are same, 2 more minutes, children, at the end of the session. When bases are same and it's division, we subtract the powers. So you can see here, cos theta to the power 4 by 3, cos theta to the power 2 by 3. Bases are same, cos theta, cos theta. Bases are same. It's division because you can see one in the numerator, the other in the denominator. So it's division. So we need to subtract the powers. 4 by 3 minus 2 by 3. 4 by 3 minus 2 by 3. Here also, sine theta in the numerator, sine theta in the denominator. So division. Power 4 by 3, power 2 by 3. When bases are same, sine theta is the base. When bases are same and it's division, we subtract the powers. So sine theta is the base. We subtract the powers 4 by 3 and 2 by 3. And when you have to take the LCM in the bracket, because the connecting sign is plus, so to merge these two, you'll have to take the LCM. Sine theta to the power 2, it's not very clear. This is sine theta to the power 2 by 3. And this is cos theta to the power 2 by 3. Let me write that alone here, children. See, you have cos theta to the power 4 by 3. Very important this is, by sine theta to the power 2 by 3 plus sine theta to the power 4 by 3 by cos theta to the power 2 by 3. Okay, the common denominator. The common denominator is the product of the denominators. Sine theta to the power 2 by 3, cos theta to the power 2 by 3. Now you need to multiply, no? So what should you do? You need to multiply this one. You need to multiply, see it's like this, right? You need to multiply these two and multiply these two, right? You need to multiply these two and multiply these two. Now again, yet another law of exponent. When bases are same and it's multiplication, we add the powers. When bases are same and it's multiplication, we add the powers. See, this is how LCM works. This is the common denominator. This is the common denominator. We have sine theta to the power 2 by 3. So you need to multiply the numerator with this one, right? You need to multiply the numerator with cos theta to the power 2 by 3. And here you need to multiply the numerator with sine theta to the power 2 by 3. So here the bases are same, cos theta. It's multiplication. You need to add the powers. So what will you get? Cos theta 4 by 3 plus 2 by 3. add the powers, 4 by 3 plus 2 by 3. So 6 by 3. And what is 6 by 3? 2. So cos square theta plus sin theta, multiplication. And the powers 4 by 3, 2 by 3. Add the power 6 by 3, 2. So sin theta to the power 2 or sin square theta divided by, so here you get sin square theta or cos square theta first. Cos square theta plus sin square theta. So that's what you see right below here. Cos square theta plus sin square theta. And the expressions in the numerator and denominator, the others, see it, cos theta to the power 2 by 3, cos theta to the power 2 by 3, sin theta to the power 2 by 3, same thing here. So cos square theta plus sin square theta, which is 1 by the identity. Sin square theta plus cos square theta is 1. So we have just, see, I did not explain this answer in the same sequence, children. I was just talking about, such places where you have to use the laws of exponents carefully. Bases are same, multiplication, add the powers. Bases are same, division, subtract the powers. And when the base is raised to many powers, multiply the powers. There's one base, but raised to many powers, multiply the powers. And then converting the radical form to the exponential form. So if you have cube root of a, this is the radical form. The same thing in the exponential form will look like a to the power 1 by 3. So supposing you have 7th root of, like b. This is nothing but b to the power 1 by 7. So please complete this paper. I'll share all these images on WhatsApp. Please work this, practice. Yeah, class, use the emoji, raise your hands. Tanya, Krishmi, Prajit, Florentina, Raja, all right, Navya is there. Raja, Madhumita, Rakshita, Krishnatik,
I'm
and
not
Navya.
able to. No,
Yeah.
I'm not able to raise my hand.
Yeah, Navya, all right, yeah. All right, children, very good. All right, children, so that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you.
Good night, children. Thank you.